Good afternoon, viewers. You are on to Mathematics with Dr. OJ. In this video, we shall study trigonometric ratios for an acute angle. Click the subscribe button below the video to subscribe to my video channel. God bless you. What is an acute angle? An acute angle is an angle that is in between 0 degree and 90 degree. It is an angle of the form 0 degree less than equals to theta and theta less than equals to 90 degree. It is not up to 90 degree, so to say. So every angle that is up to 90 degrees is called a right angle. It's called a right angle, and it's called a right angle rather. So in this case, now let's look at the ratios of an acute angle with respect to sine, cosine, and tangent. Now, suppose we have a right angle triangle ABC, a right angle triangle ABC. So let's call this our acute angle. Remember I said it's an angle that is less than 90 degree. It's between 0 and 89.99 and stuff like that. Okay, now using SOHCAHTOA by SOHCAHTOA, which we had learned in our elementary mathematics. Okay, the so there means so stands for what? Sine, which is what? Opposite. That is O stands for opposite, H stands for hypotenuse. Okay, and our CHA there, CHA, stands for cos, which is what? Adjacent all over hypotenuse. And the last one there, TOA is equal to what? Tangent, which is what? Tangent is equal to what? Opposite all over adjacent. Okay, so suppose I call this let's call this y, and I call this x. Okay, and I call it anything. It depends on whatever interest I want to fashion out there. Now, so if I call this xy, the hypotenuse side will equally need to be found. So let's call my hypotenuse side. Let me call it r. Okay. So now, if I want to find the ratio of sine here, I'll be saying sine theta is equal to, now the side facing, because it's opposite, the side facing that theta be my what? Will be my opposite, y all over hypotenuse. Hypotenuse is the longest side of every right angle triangle. Is the longest side, the side that has the longest length. So the longest side there is what? R. So my sine theta here is y all over r. I hope that is noted. You can call this one equation I if you like. Now for cos theta is from cos, adjacent over hypotenuse. Now our adjacent is what? Is x. Okay, because we said this is the hypotenuse, this is the opposite. So the adjacent will be x all over hypotenuse, that's r. And call this one equation I. And tan theta, which is the opposite over adjacent, that's y all over, what is the adjacent there? X. So you can call this one what? 3. We can get tan theta from from sin theta and cos theta. Let's check something there. Let's check. Suppose that now if we divide, let's say sin theta over cos theta, let's see what it's going to give us. Sin theta is y all over r over cos theta is x all over r, which implies y over r divided by x over r, which is y over r times r over x. This cancels this. It's going to be what? Y over x. So from here, that means sin theta over cos theta, it's the same thing as tan theta. That is clear. Okay. Now, you can find the reciprocal of these values. You can find the reciprocals of these values. How do we find the reciprocal? Now, if we say 1 over sin theta, that will be what? 1 over sin theta is what? Y over r. So that will be automatically r all over y. The inverse will be upside down. So this 1 over sin theta is called cosec theta. Cosec theta is 1 over sin theta, which is r all over y. So we can call this one equation 4. Then similarly, we can find the reciprocal of cos theta. That is 1 over cos theta, and that's what? 1 over x all over r. So by the time we find the inverse, we're going to have r over x. That gives us equation 5. I hope you understand. Good. Now, how do we find the inverse? And we call this 1 over cos theta is called what? Is sec theta. So sec theta is 1 over cos theta. So let's rewrite that 5 there. That's that for that. Now the other one, which is the last one here, let's find the reciprocal over tan theta. 1 over tan theta, and you know tan theta is x over y. I think y over x, or what do we have there? Okay, so that will be what? 1 all over y over x. What? X all over y. X all over y. Okay, now that will be what? And tan theta is called what? Cos theta. The reciprocal of tan theta is called what? Cos theta. Okay, so that is it. X all over y. You can call this one equation 6. Okay, now let's look at, we have examples. Let's look at that. Let's look at that. Let's look at that. Now there's something let's look at how we can generate the square of you know, x and squares and sine, and see what it's going to give us. Okay, in this particular equations that we've gotten, let's look at if sine theta is I think our sine theta is I think, let me quickly, because I didn't write it down, that's y, r is x, that's opposites, y all over hypotenuse. So my sine theta is what? Y all over r. Okay, so my sine square theta, that is, if you find the square of this sine theta, that will be y all over r squared. That will be what? Y squared all over r squared. Okay, now I can also have my cos theta is and that's x over r, x over r. So cos square theta is when you multiply cos by itself again, x over r squared. Okay, cos square theta means cos theta twice. Okay, that will be x squared all over r squared. So now let's look at, if we have the two together, let's call these equations 7 and 8. 7 and 8. Okay, now adding the two equations, adding equation 7 and 8 together. Let's look at that. Okay, y squared all over r squared plus s squared all over r squared. So what are we going to have? The LCM is r squared automatically. So now r squared in r squared, that's 1. 1 times y squared, that's y squared, plus r squared and r squared, that's 1, times s squared, that's s squared. Now, if we look at our geometrical right angle triangle that we use to get the ratios of our acute, we observe something here clearly that from, let's call this one equation 9 now. Okay, I say from the right angle triangle, triangle by, you know, Pythagoras theorem, you know that r square is equals to y square plus s square, because the Pythagoras theorem says that the square of the square of the length of the hypotenuse side should be the sum of the squares of the other two sides. So r square is equals to y square plus s. So let's call this one equation asterisk. Now putting asterisk, by putting that equation asterisk, by putting equation asterisk in equation 9. At the time we put equation asterisk in equation 9, okay? So they have what? They have what? Now have what? Y squared all over r squared plus x squared all over r squared is equals to, now our y squared plus r squared is now r squared. So you can replace that r squared over r squared. So what happens? That implies that r squared over r squared will be what? Which is equal to 1. Therefore, y squared all over r squared plus s squared all over r squared is equals to 1, which implies that what the square of the ratio of sine plus the square of the ratio of cosine will be equals to 1. That is, sine square theta plus cos square theta is equals to 1. This is a very standard formula which we should bear in mind. We'll call this equation 10. Okay, so on this note, we're drawing the curtain of this particular aspect. So when we meet in our next video, we shall continue from here. Thanks and God bless you.